In this video, we'll introduce some fundamental terms for vehicle kinematics. A quick remark before we actually start. All the definitions in this video actually adhere to the international standard ISO 885 on the terminology for vehicle dynamics. First, the wheelbase, which we denote with a lowercase letter L, is the distance between the front and the rear axle of a vehicle. Then the track, which we denote with a lowercase letter b, is the distance between the left and the right wheel. And actually that may be different for the front and rear axle, so we could distinguish between a track of the front axle and a track of the rear axle. As we have already seen in the previous video, when we looked at the definition of the different coordinate systems, the horizontal plane is defined as the plane that is orthogonal to the direction of gravitation and that passes through the vehicle reference point. The road plane is the plane tangential to the Earth's surface, which we assume is a differentiable solid surface like a road at the vehicle reference point. Based on this, we can define the slope angle, which we will call by the Greek letter lambda, as the angle between the horizontal plane and the road plane in the direction of the x-axis. Recall that the x-axis refers to the horizontal frame. And finally, we call the bank angle beta the angle between the horizontal plane and the road plane in the direction of the y-axis of the horizontal frame. The vehicle velocity vector v of t and the vehicle acceleration vector a of t are the first and second order derivatives of the inertial coordinates x, y, and z with respect to time. Note that the first order derivatives are denoted with a dot and the second order derivatives with a double dot over the corresponding letter. If we project this velocity vector v of t and the acceleration vector a of t respectively onto the horizontal coordinates, what we get is in the x direction the longitudinal velocity v ln of t and the longitudinal acceleration a ln of t. In the y direction, the lateral velocity v lat of t and the lateral acceleration a lat of t. And in the z direction, the vertical velocity v vert of t and the vertical acceleration a vert of t. The yaw angle of the vehicle, that we denote with a lowercase Greek letter psi, is the angle between the x-axis of the inertial frame and the x-axis of the horizontal frame. So you can also think about the yaw angle as the vehicle's rotation angle about the z-axis. And that's illustrated in the figure on the right-hand side here. The corresponding angular velocity, psi dot, is called the yaw rate of the vehicle. The pitch angle of the vehicle, which we denote with a lowercase Greek letter theta, is the angle between the x-axis of the horizontal frame and the xv axis of the vehicle frame. Or if you will, the pitch angle is the vehicle's rotation angle about the y-axis. And the situation is illustrated in the diagram on the right-hand side. The angular velocity theta dot is called the pitch rate of the vehicle. The roll angle of the vehicle, denoted with a lowercase Greek letter phi, is the angle between the y-axis of the horizontal frame and the yv axis of the vehicle frame. Or in other words, the roll angle is the vehicle's rotation angle about the x-axis. And you can see the right-hand figure for an illustration. And analogous to the above, we will call the angular velocity phi dot the roll rate of the vehicle.